Hey guys, a wonderful day. So basically for today we are going to learn on chapter 3 physics semester 1 from the Malaysian matriculation syllabus. It's going to be momentum and impulse. Okay, this chapter is literally quite short. We are going to go through the concepts from this chapter, the very important concepts. So basically in this chapter you got to know all these concepts and formulas. That's it. And you can solve whatever questions which comes up. Chapter is quite short, again I repeat, and it's quite simple actually. Okay, now let's move on to momentum and impulse. Number one, as usual, you gotta know definitions and formulas and how to solve the problems using the formulas. Those are the main three things in physics. Okay, let's go number one, momentum. What's exactly momentum? When we are talking about momentum, momentum is defined as the product between mass and velocity. Okay, so what's the formula? P equals to mv. Don't forget, mass is not a vector quantity. Momentum is a vector quantity because velocity over here is a vector quantity. That's why the arrows are only for the P and V, not the M. Okay, P equals to mv. So if you solve mass is kilogram, velocity is meter per second. So the SI unit over here, you will be getting kilogram meter per second. Or you can write it like this, kilogram meter per second, but it's best for you to write the first one. Okay, it's quite clear. All right, that is number one. Number two, what you got to know about momentum is resolving those momentums. Okay, as usual, in this chapter, the most important thing is resolving vectors. Let's say they were to give you P over here. You got to know how to find, let's say they give angle theta equals to 30 degrees. You got to know how to find Px and Py. I guess you guys are very familiar with P cos 30 degrees to find Px and P sine 30 degrees to find Py. Why do we do so? Because in this chapter also, ada juga your table kena buat X dengan Y punya komponen. Okay, kali ni table dia bukan Stuva, okay? You have to do X dengan Y component untuk maybe momentum, maybe something else. We will learn it very soon, okay? Alright, that is the first part. Okay, don't worry, this chapter is very, very short. Let's move on to the second part. The second part, let me use green. The second part is impulse. So when we talk about impulse is basically defined as the product of force and time. So I think you guys can know product of force and time. Kalau tak tahu, jangan risau. Ada formula J equals to Ft. J is the symbol for impulse. F and T is the product between force and time. That's how you get the impulse. Okay. Now, what is the SI unit? SI unit is Newton second, not per second, okay? Newton second or kilogram meter per second, okay? Newton second or kilogram meter per second, okay? Don't forget over here, impulse also is a vector quantity. Why do I say so? Because over here, force is a vector quantity. Definitely, when force is a vector quantity and time is not a vector quantity, the value or the unit of impulse or the type of quantity of impulse will be a vector quantity. Okay, now that is basically for impulse. Okay, impulse over here, we are going to learn a little bit more actually. We're going to relate this thing, and so on for your calculations. All right, now before I move on, let me just write down a relation over here. Impulse, okay, J is impulse kan, is equals to tadi apa? Force times time. Okay, force times time. Now, force impulse is also equals to the difference or final momentum minus initial momentum. So basically, change of the body momentum. Okay, impulse is equals to Ft. Impulse is also equals to change in momentum. Final momentum minus initial momentum. Impulse not equals to momentum tau. Impulse is equals to the change in a body's momentum, which literally means final momentum tolak initial momentum. Okay, that's all you gotta know. Now, let me open up another page. Another important part about impulse or impulsive force. Tadi impulse kan? Sekarang impulsive force. Okay. Impulsive force is a type of force. Tadi is just merely impulse. Now, impulse is J kan? Impulsive force J equals to Ft kan? Okay. J here is impulse. F here is a force. What type of force? Impulsive force. Okay? Alright. Make sure you guys know the difference. Okay. J equals to Ft. F kena darab dengan T. Masa dalam chapter 1 last time, chapter 2, we have learned about graphs, right? So when graphs, apa-apa darab is this unit darab dengan this unit. Basically, y-axis punya unit darab dengan x-axis punya unit. Okay. Nak darab maksudnya apa? Area kan? Kalau gradient is bahagi sebab y over x, itu gradient. Kalau area is y times x, itu baru area. Okay. So, impulse punya graph is force against time. So, usually impulse punya graph punya shape will be like a bell shape lah. Okay. So, nak cari impulse, you don't do divide. Kenapa? Kalau divide, Ft negative 1. Adakah itu unit bagi impulse? No. We want it Ft. So nak buat apa? Darab. So we know properly or we know very well, darab adalah untuk area under graph. Tadi bahagi is what? Bahagi over here is gradient kan? Okay. So the area under graph of an Ft graph is impulse. So dia bagi graph ni, dia suruh cari what is the value of impulse. Just find the area under graph. Okay. Alright guys. Guess what? That's all for momentum and impulse. It's very, very short. Okay. Now, let's move on to the second part that we are going to learn in this chapter. The second part that we are going to learn in this chapter is principle of conservation of linear momentum. Okay. Now, what is the meaning of principle of conservation of linear momentum? Number one, you got to know what does this principle state. Kena tahu apa principle ni cakap. Principle ni cakap in an isolated, okay, atau close, in bracket close, okay. In an isolated or in brackets closed system, isolated system, the word is very important, okay. Tiada perkataan tu, no marks. In an isolated system, the total momentum of that system is constant. Okay. Before we move on to the explanation of this particular concept, let me just reiterate over here. Principle of conservation of linear momentum states that in an isolated system, the total momentum of that system is constant. Okay, isolated system maksudnya apa? Let's say there's a ball moving from point A to point B. Okay? Maksud dia, the ball is moving with the force sekali macam tu. Okay, the force sekali, lepas tu dia move lah. Maksud dia dekat tengah-tengah ni tiada gangguan apa-apa. That is the meaning of an isolated system. Just a particular force pushing it, that's it. Tengah-tengah, while it's traveling, tiada gangguan apa-apa. Alright, that is what we call in an isolated system. Alright, now, how do we apply this principle into formulas? Dia cakap apa? Total momentum is constant. Total momentum tu apa? Kan just now we have learned final momentum, initial momentum. That is impulse. Final momentum tolak initial momentum. Now, it's principle of conservation. You nak conserve momentum tu. Jadi, sum of initial momentum equals to sum of final momentum. Boleh juga jadi sum of tadi P equals to apa? MV kan? MIVI atau initial mass, initial velocity. Selalunya final dengan initial mass will be the same because we're talking about the same object, okay? Equals to, okay, same thing. Kenapa? P equals to MV. So initial momentum equals to final momentum. Okay. Now, let me move on to an example. Alright, okay. Let's say we are talking about a ball. A ball, let's say a ball moving this way with 3 meter per second. Itu velocity dia. Ball dia apa? Let's say 1 kilogram. Next, that is the initial momentum. Next, we are going to be talking about another ball. Let's say another ball, ball B. Okay, let me use blue color. This ball is moving this way. Let's say it's moving at 6 meters per second and the weight of the ball is 0.5 kilogram. It's stated clearly that it has to use the principle of conservation of momentum. Okay, dalam case ni, you can very clearly use initial momentum equals to final momentum. Alright, selalunya soalan akan suruh cari apa? Maybe suruh cari ni, so they won't give you the velocity. Kenapa? M equals to mv. Okay, so sebenarnya kalau macam ni, you have to find the final velocity. Alright, now let me explain how do you apply this particular formula. We are talking about the same ball. Maksudnya initial dia pergi situ, lepas tu dia kena something and then it comes back, okay? If we are talking about separate balls, let's say ada ball A and ball B, you have to put MAIVAI plus, because total kan MBI plus, sorry, VBI equals to MAF VAF plus MBF VBF. Itu kalau dua bola. This one we are talking about only one ball. Okay? Because initial momentum equals to final momentum. Alright. Jangan lupa, kalau bola tu pergi belah sini, kita dah belajar dulu vectors. Left and down is negative kan? So you just put on the velocity over here negative 6. Macam tu. Have to put negative, okay? Remember, have to put negative kalau dia left and downwards. Kalau right and upwards is always positive. Alright? Depending on the number of balls that you're using. Alright. Just now, initially, I've stated about vectors being important over here kan? Resolving of vector. What do I mean? Let's say, dia pergi situ. Lepas tu masa dia balik, dia dipantul like this. It didn't balik straight macam tu. Dia balik bawah sikit. And the angle over here is 30 degrees. Now, you have to find the momentum kan? Simple thing. Same thing. Nak cari yang ini, kena cari you punya X component dulu. Lepas tu Y component. Lepas tu resolve, then you'll get what is P. Just the exactly same thing. You just have to resolve the vector and find the value of yang warna hitam ni. Sekejap, let me just highlight it a bit more. Yang warna hitam ni. Because kenapa? Dia moving this way, not moving here. It's moving in a 30 degree position. So you have to find the value of that momentum by resolving vectors. That's the simplest concept. Alright, okay guys. So that is basically all about momentum, impulse, and principle of conservation of momentum. That's all for the formulas, okay? Don't worry much, this chapter is quite direct. Now, let's move on to the second subtopic. Tadi point kedua kan, that's the first subtopic. Got 2 points over there. Now we are going on to the second subtopic. In this subtopic, we are going to learn on collisions. Okay, dulu you guys know very well, we have collisions. We have elastic and inelastic, okay? Okay. Number one, you have to know what is collision itself. Definition dia penting. Alright, let's do it together. Collision is defined as an isolated system, isolated event. Tadi in an isolated system. Ini collision is defined as an isolated event. Maksudnya event tu Tiada gangguan apa-apa. Same thing lah, obviously, right? Event in which two or more bodies maksudnya dalam sini object. An isolated event in which two or more bodies exert, you put in certain thing, exert relatively strong forces on each other for a relatively short time. Okay. Apa maksud dia dekat sini? Collision kan dia akan berlaku sekejap je. Lepas collision tu, it either separates or stick together, right? So it's an event, it's an isolated event. Remember, isolated event, which two bodies. It can be three bodies, it can be four objects, it can be four cars, it can be four cranes, it can be four marbles, 5, 6, no matter how many, but minimum two, comes together with a force. Kan kalau benda tu nak move, it has to have certain force, and we call it impulsive force. Initially, kita belajar impulse, right? But right now, force. We don't know what kind of force. Okay? Moving towards each other, in this subtopic for collisions, we are just assuming a particular force moving, okay? So, two particular bodies moving towards each other. Let's say here, move towards each other. Another ball. With an exerting relatively strong forces on each other for a relatively short time. Maksudnya benda ni nak datang sini, or benda ni nak datang sini, makan masa lama. Tapi collision, where both of them collide, sekejap je. Lepas tu akan jadi something else. It's either they move away or they stick together and move somewhere. Alright? That is the general definition of collision. Now, let's move on to the specific definitions, okay, of elastic and inelastic collision. Now, when we're talking about elastic collision, it's defined as one in which, okay, one ni merujuk kepada collision tadi, elastic collision. Or you can still write again lah, elastic collision is a collision in which the total kinetic energy, remember kinetic energy of the system is the same before and after the collision. I repeat, elastic collision is defined as one in which the total kinetic energy, okay, total kinetic energy of the system is the same before and after the collision. Okay, please bear in mind, total kinetic energy ni, we are also talking about kinetic energy and also total momentum pun included, okay? Alright. Maksud dia apa? Let's say a ball comes towards you and another ball comes together lah basically. Dia collide, lepas dia collide, apa akan jadi? It will separate. Okay, dia elastik ni, contoh yang paling senang, the way you can remember it is getah. You elastik dekat dinding, dia tak lekat kat dinding kan, dia datang balik. Same thing over here. It hits and it moves towards its own direction. Tapi remember, total kinetic energy atau total momentum is conserved. Okay, before and after collision is just the same. Okay. Now, let's move on to inelastic collision. I'll write over here in green, inelastic collision. So, inelastic collision is defined as one in which, one to simply refers to the collision itself, one in which the total kinetic energy of the system is not the same before and after the collision. Okay. Now, I repeat, inelastic collision is defined as one in which the total kinetic energy of the system is not the same before and after the collision. Okay. Maksud dia, a ball comes this way and another ball comes the other way. What happens next is they collide. What happens next? Let's say ball A adalah lebih berat and lebih laju. and ball B adalah lebih ringan and lebih perlahan, of course dia akan ikut direction ball A. So it will go to the right. Both the balls will go to the right. Okay. Dia macam tu konsep dia. Alright. Dia macam, let's say plasticine, dua plasticine comes together. It will move a certain direction. Dia akan melekat and move certain direction. Okay. Now, for you guys to know, tadi kita dah bincang on the definitions, right? Now, let me clear things up. When we are talking about elastic, specifically about elastic, kita cakap initial and final kinetic energy is the same. Okay? Maksud dia, total kinetic energy is conserved. Okay? Next, elastic juga tadi kita cakap initial momentum dengan final momentum adalah sama. Maksud dia, conserve juga. Okay, remember very carefully. Untuk kinetic energy, what's the formula of kinetic energy? 1/2 mv square, right? Okay. Why do I say this is important for you guys to know? Belah sini, you nak guna 1/2 m initial, I use U sebab initial velocity. Square equals to 1/2 m final v final square. That is the meaning over here. And untuk momentum pula, we will be talking about mv equals to mv. Because P equals to mv, right? Sorry, P equals to mv. Okay, sini guna U sebab initial velocity. Okay, that is elastic collision. When it comes to inelastic collision, tadi kita bincang apa? Inelastic collision is defined as one in which the total kinetic energy of the system is not the same before and after the collision. Okay. Inelastic collision, which means your initial kinetic energy is not same as your final kinetic energy, which means it is not conserved. Jadi you cannot be using this formula yang ini equals ni untuk inelastic. Kenapa? It's clearly stated inelastic is not equal initial kinetic energy and final kinetic energy. Next, it's stated very clearly that the momentum is conserved. Maksudnya you can use, it's conserved, okay? Conserved. Maksudnya you can use the same thing for inelastic collision. Alright, remember kalau dia tak conserve, maksudnya initial dengan final tak equal. Maksudnya sini 1/2 mu square is not equals to 1/2 mv square. Tapi untuk elastic, yes, it's equal. Why? It's conserved. Okay, that is the concepts that you guys need to know in this chapter. Okay, how do we solve calculation? I'm just going to give you guys guidelines and tips from this chapter on how to solve calculations. Number one, always do component by component. Let's say we are talking about particular object A, buat untuk A dulu. Kalau B, buat untuk B dulu. Final, initial. Then you do the equations. Macam mana nak buat equations? You can use P equals to MV, J equals to FT, J equals to MV initial minus MV final minus MV initial. Basically change in momentum. Then you can also use principle of conservation of momentum where initial momentum MV initial equals to MV final. You can also use from collisions, elastic and inelastic collision punya formula. Okay. Next, when we are talking about calculation, we also need to calculate kinetic energy accordingly. Okay. Kalau dia cakap pasal elastic, inelastic, no. Perlu tahu mana satu equal, mana satu tak equal. Kalau tak equal, automatically, nope, don't use this formula. Unless dia bagi initial kinetic energy is this, then you can use the formula. Okay, let's say dia dah bagi siap-siap value dia, then I think normal mathematics you can do the calculations. Okay, that is number 2. Number 3, remember tak untuk when we are talking about elastic collision, the mass is same. So you can always use, because you can always factorize kan mass dia. So you can always use the same thing. When we are talking about one object, initial dengan final velocity je berlainan, tapi mass masih sama. So that is how you factorize for one object. Kalau dua objek, jangan factorize. But it's best for you to stick onto the formula. Okay? Alright. Okay. Guys, these are the things that you guys need to do and to know from this chapter. That's it from this chapter. We are done with this chapter. I'll be giving you guys questions and we'll go through on techniques on answering chapter 3's questions. Okay, so for your homework, what you need to do is to rewrite everything that we have learned over here and do a set of notes. This exact thing, whatever you guys have listened, you guys write down whatever you guys have seen over here on our live board for today. You guys write down very neatly on a piece of paper or 1 or 2 pages. Make a note for yourself and then pass up that notes to me. I will double check that notes whether it's all perfect and then we are good to go to the questions. Okay, guys, that will be your homework. Okay. Thank you very much, guys. I hope you guys enjoyed this session. Happy study, guys.